Hi everyone. So I welcome you all for today's topic, fuzzy face detection. Myself, Kartik Sain, presenting this topic today and sharing my knowledge with you, everyone in this room. And I will be happy to have some queries in the end of the session. And let me brief about myself so we can start the session right now. Uh, so let's so myself is Kartik Sain, and I am working as a senior technical leader in the media kind as of now. Uh, so my total years of experience is near about 12, more than near about 12, and basically I have on the consumer electronics and embedded systems where I have developed the applications Netflix and Prime Video for the Samsung Smart TV that has surpassed the market competition. These applications are OTT streaming apps, and currently at MediaKind, I am working on similar projects for the Roku devices. So I apply my experience into these apps and have machine learning and AI technologies. Also, I have very much interest. So I will be bringing the topic today is face detection. The face detection, we all know that we have to detect the faces in the images. So today we are going through uh, these four sections: the face detection, the challenge, the algorithm adopted during face detection, and in the last we will do just wrap up. So let's continue the face detection. The face detection, everyone understands that whether we have to do the detection of the faces in still images or in a video. So here, if we do detection of the faces in the video, we have multiple frames of a same uh, image, like we have a left and right, and because the object is mostly moving, like right now, I am moving and rest of the scene in the room is still. So it's pretty much we can isolate the object with minor doing the frames positions, and we can isolate the bounding box around this object, and then later then we can just throw this bounding box into some algorithm and we can just get out what filtering. So my idea is also similar to have this face detection in a different approach. But basically, we are just checking these into two parts, like what we do in our video frames, so and still images. So here we are mostly focused on the still images. In still images, we are focused as of now because in still images we don't have multiple frames to detect directly the object. So here, face detection is a technology where we identify the faces in the object, and then we can do multiple applications like recognition, tracking, emotion of the faces, everything. So it's like a base steps to any other algorithm. So there are multiple approaches for this. Like we classify them into two parts: feature-based approaches and the image-based approaches. So feature-based are further classified like low-level feature analysis, template. We have a template of face. We can, or some rules, bounding box rules, or we can apply some support learning vectors, learning SEM, and these algorithms we can do in a hybrid mode also, using some feature-based and image-based. So my idea of approach is of hybrid, where we use both of them. And let's discuss next the challenges. When we do still images face detection, there are multiple challenges. So these challenges are, we can classify like image plane variations. If you see suppose there are multiple faces in an image, there are image where we have the background color are syncing where I am highlighting my cursor. So there are like skin color. Even this hand is also have a skin color if we do directly skin color. Although I am using the skin color in my approach, and here also the lighting variations are very much prominent. It's not easy to detect the objects. So to deal with these types of challenges, my approach has been further down. So algorithm adopted. So in this algorithm, we have several steps. We call it this algorithm as a fuzzy face detection. The fuzzy means it's not discrete to have like only belonging to particular set. So here we are saying fuzzy because anything can belong to anything, and we are not sure which data will be belonging to which set. So fuzzy is like a degree of association or degree of uh, we can say how much it's aligned to particular similarity to particular model. So here are some steps we use into our approach. These are color space modeling, space used for skin modeling, and then we do the skin color segmentation using fuzzy C-means algorithm. That is the AI logic to do unsupervised learning, and then after we do unwanted regions removal, and after that we apply set of rules that we call as a fuzzy, means some not discrete value of something, like it should be hard coded value something. And further we do the I region localization, and based on the region localization we have a decision rule to go with a face prediction is done or not into the particular image input image. So we can understand in a way like for this algorithm we have these many of steps which we have to go through, and then we have finally the face output. Although it seems to be in the algorithm complex, but it's not that much complexity. Everyone not have to do every step once the algorithm is completely. So am it seems like my sound is not getting clear. So just wait for a couple of minutes. Let me check. Uh, I hope I will be audible right now, and I will go slowly so that everyone can understand what I am trying to convince. Here, but my algorithm has, so I will be repeating this slide just to understand. We have a number of steps. The steps we focused on the fuzzy face direction, the color space used for skin modeling, skin color segmentation. I think I have a background noise. That's why my uh, let me switch it off something. So let's continue. Uh, I will try to continue. Color space used for skin modeling, skin color segmentation using FCM, and then we walk through removal of unwanted regions and noise, fuzzy rules for the first step elimination, I region localization after it, and then went through the decision rule. So let's continue for color space used for skin modeling. Here we know we have input RGB image, red, green, blue, with say 8-bit color image, uh, and we modify the color space to the YCBCR. But in our approach, we have taken the Y as a Y dash and the CB as a CB dash, although it's the same, but we still denote as a Y dash and a CB dash because we are modifying the third channel CR dash. So CR dash is CR minus alpha by beta. So in this way, we modified this RGB space to the YCBCR dash. And just to visualize how the colors will get changed onto the image, I have taken the output from the input RGB image and walking through the how this algorithm will be giving the results during this algorithm explanation. Here, after modifying just give me 1 minute. I am already using the headphone, but I still think there is some weird problem, maybe some other technical issue that I am not able to get on the screen. So I think I will be speaking loud right now, so it will be hearable at least rather than noise. So let's modify CBCR color space helps us to detect the skin color for the skin modeling. So why we have chosen this we have to filter out, first of all, we have an image, and you can easily observe that the many skin colors are matching with the background browns in this image. So it is not easy to detect skin pixels directly. So once we transform into the modified CBCR, we apply next rules of segmentation of the skin color. So here I will say skin color segmentation. We apply skin color segmentation only using the fuzzy C-means algorithm. The CR channel of the using fuzzy C-means create the clusters of the CR channel, because CR channel contains only the data points, and these data points are collected into the clusters. These clusters are also limited. We have not limitations like we can create multiple clusters of the CR dash. Uh, Already we have normalized the CR channel earlier by modifying the color space. Now, after creating clusters of CR channel using fuzzy C means, we cluster them into 12 clusters and go with a cluster validity for the given input image. So once we apply this cluster, we have a threshold for each cluster, whether it's qualify a skin color cluster or not. So based on that, we get few clusters get filtered out of which using the tmin and tmax, these are the uh, experimental min and max based on the cluster min and max. So these are decided basically on the experimental region, not hard coded. Just for the data set I have using, I have put it into it and calculated. So after that, the first channel y dash, we also filter it based on the y dash. If you see here, the false positive of brown is coming still after doing the cluster and going only skin. Skin is detected very well, although hairs are also coming here, and this brown region is also coming. So just to eliminate that, we filter on the y dash. Y dash is the intensity values of the YCBCR. So YCBCR gives you the intensities of the each pixel. So if we filter on the y dash, so y dash, after filtering on the y dash, the y dash will be like we can say besides skins pixels false positives. So here this brown region is totally eliminated after filtering onto the y dash. Now we can easily see the only skin colors are coming into our output image. Just to although it's running into the algorithm and where I have collected the data, then printed out to the RGB image basic on the whatever data I have left with me based on the clusters indexes. So based on that, I have generated this image, and we can easily see that only skin, hands, even hands are also false positive, that we will see into the later stage. So at this moment, I can summarize like skin color segmentation onto the CR dash channel applying using fuzzy C means. We have first make the clusters of the skin indexes and then filter out the skin indexes clusters on the tmin and tmax, and then further thresholded based on the y dash intensities, because the skin colors will have low intensities and where have y dash will be high intensities, pixels are eliminated in a simple way. We like this. So let's move on to the next method. Here, after getting the previous image, we have just make the grayscale image, and then we have done the binary. Whatever we have just make a 0 1 of that image, and we can easily see the white as the candidate of the skin pixels, and we are just doing, after that we are just doing the morphological opening of disk radius 1, and that eliminates this eyes from this image and gives the clear full cluster bound of it. And then we just do the whole filling and make the smoothing effect onto the skin pixel so that we can get maximum area to detect. After that, we just label out whatever the regions, how many regions we get as a let me try with my without the headphone then. So we are discussing removal of unwanted regions. Hopefully, I am now more audible rather than previous. Okay. So I think headphone is creating issue. So I've removed the headphone and directly using.
my PC. So let's continue to the removal of unwanted region noise. So the image we get from the previous, this after doing the skin color segmentation and applying the fuzzy semis algorithm, we just transform into the grayscale and we then do the binary. Grayscale is just we are just doing the averaging of the RGB, and then we whatever the values of intensity we are just uh, doing the binary of it 0 or 1. So based on that, we can easily remove morphological opening by disk of radius 1 mean. We are applying a small filter and we are just making sure that these eyes should also become as our candidate, and we have a greater area of to detect. Otherwise, there will be so many small boxes will be creating in the later stages. So just to avoid, because face is a big area, including eyes, nose. So that we have detected the skin, but we have to choose more area. So we do the morphological opening, and further we again do the hole filling so that we have more area to fill it up, and we have absolute contenders for the face detection. After that, we just label up the regions onto the different colors just to have the labeling of the regions that we are creating these bounding boxes around those regions. And even you can see these small boxes also getting created, these small boxes, and this box also, and this box also. So these all are becoming the candidates for the next step of the algorithm. So these all bonding boxes with the red will go into the next steps, and then we proceed with our next part of the algorithm. So here, using the bonding box, we have set up some rules. These rules are basically width is small and height is small. Then we can say it's a non-phase. And if width is small and height is high, then also a non-phase. If width is large and height is small, then also a non-phase. If width is medium and height is small, then also a non-phase. If width is large and height is large, means multiple phase. Width is small and height is medium, then phase. Width is medium and height is large, then phase. So these rules we have created where small, high, large, and mediums have different number of values based on the image area. Basically, we have some ratio context to the image. Like if we have an image of 256 by 256 or 512 by 512 or 1024 by 1024, so how much we can consider a width and height in a image? Like this should have some ratio into it. So applying these types of fuzzy rules, we have like bounding boxes here on the hands, here also on the hands. When we apply this algorithm and we apply these rules to filter it out, we can see easily see that output has been changed. All the four faces are coming, and the rest all small boxes has been removed from the hands. But there is still a false positive is there. So to deal with these false positive, we have some next step into the algorithm, and these all five contenders now in this image, as per this image, will proceed for the next step of the algorithm. And we have isolated, we have removed this unwanted regions of the with this step. So this greatly improves our accuracy into the algorithm. We don't have this false positive. Also, with the lighting variations, when we have used skin modeling, this phase also get removed with lighting variations, or this is also coming as a big bounding box, although the face is very small into some other algorithms. What we are experiencing at our experimenting time. So after this, we proceed for to the next step of the algorithm. Here, into the next step algorithm, we have a I region localization. When we have eliminate all the non-phases by our fuzzy rules defined, this segmented image still containing the noisy or face-like region, which is similar property to the faces, like we have seen a hand image into coming into. So there is a formula given by HSU, which you apply onto the CBCR channel, and we can easily identify the eye maps onto any bounding box. So here pass uh, our input box to this eye map, we can easily see that eye region has been very high intensities are coming. So this we detect in the intensity region that after passing this we have high intensity zones or not. So based on this, our algorithm will not do anything onto the white part because it knows its boundary already into the previous image because the boundary is maintained. Not only the bounding box, boundary is also maintained into the algorithm. So this I region localization is the final step, we can say. And based on this, if we have the I region into our this I region into our any existing bounding box, then we decide as a decision rule to occur to declare it as a that phase is present. So final elimination of unwanted region are done with this decision, and where have we have I pixels, we declare it as a phase. So here we have a false positive earlier, which we can see into previous image here. Here we have a false positive hand is coming. But after applying I region localization, and we have passed all these, not only this, we pass all the bounding boxes. So, but not these bounding boxes, which are eliminated by the fuzzy rules. Here can be a possibility that phase will be also, but these fuzzy rules are so such that it will remove only the small areas like small bounding boxes, not the bounding boxes which are exactly as per the face uh, geometry. So we can say here we are good to go with these fuzzy rules. And when we pass all these five contenders, one, two, three, four, and five, this hand is also passing. Because if you see just a bounding box says that it is creating an area of a face because width height is similar and having a skin pixels. So that is the false positive into any still image. Wherein video, we can easily neglect because we have multiple facial movements into the video streams where we can minus the two frames and get the difference of the two images. Here we don't, in still images, we don't have this previous data in the next data. So we have to rely onto a single data of this image. So further, after passing this, we can easily see this eye regions are getting highly high intensity zones. So all those five get passed through them, and then we can see here in the decision rule if I is present then face, otherwise non-face. So algorithm approaches in a very simple way, although it has multiple steps. The approach is taken like we are doing the skin color segmentation using the modified color space using the YCBCR dash. Onto the CBCR dash, uh, we are so this gives you the results. So I would further move wrap up. So what we have discussed is what is the face detection and the approaches, the challenges we in of the face detection in the images, still images, and how this algorithm can solve the problem of soft face detection in still images. So here we are seen that in the still images, we have pose variations, skin variations, intensity variations to detect, and we don't have any prior data of video frames. So detecting in a still image is more complex rather than in a video. So this algorithm has approached it, and for the further, we can have fuzzy face. You can refer this report, a complete detailed report where and the I algorithm. So I would like to thank you all, and if you have any queries, we can discuss right now. So let me summarize this session. So here we have discussed fuzzy face detection algorithm, and we have uh, rules where we go through these rules for the fuzzy face detection. We use the color space for the skin modeling, skin color segmentation with using fuzzy C means, removal of unwanted regions and noise, and then applying the fuzzy rules for the first step elimination and eye region localization. So here is a query like how to apply the fuzzy face detection with practical examples. So for the practical examples, I have taken these data from the practical example only. So it's not like we can uh, you can choose your own programming language, any other language. I've used this practically basically into the MATLAB as we get the APIs directly to use it. So as of now, I cannot directly show the steps, but if you apply directly in any rule, I have taken this practical examples only, which we have applied my algorithm directly. So it takes some processing. It's where I have to do this RGB transformation to ICBCR, and then if we do the skin color segmentation, it takes processing of the time, and that's why the practically directly we cannot do direct here at the moment. It takes multiple sequences to the cluster, and once you have this data with you, and then you can pass it to the and make your uh, complete architecture based on it. So these are the practical examples which we have taken from the data directly. Here you can observe that these images are, after applying these areas, are getting eliminated. So these are the outputs of the practical. But if you to do, we have to set up a complete MATLAB programming, or you can use it in any other language also if you apply similar logic. So you have to decide where how we can. You have to approach this method. Any other QA I would like to answer if I can. Yeah. So we can say like in I have a comparison earlier. So I have not put it here just for because I don't want to complex my slides right now. If we that dark skins, if we go back to our images like here, here I have said that we have these challenges: image plane variations, pose variation, lighting variations, background variations. So these dark images also, if you process, And when we do the skin color segmentation using the modified CBCR, so that dark skin pixels also comes into the picture, and that gets created into a cluster. So why we are using the clustering fuzzy C means, uh, fuzzy C means here we are passing this CR channel because we have normalized the CR channel range, and then we are approximating using making the clusters of that data points. So that data points will have dark skins also, but those are not directly we can say a black pixel. Black pixel you see onto the image because of the y dash, because of the intensity of that point. But in the CR dash, you will not see that as a black pixel. Black pixel is, we can say, all are 0 or all are 22555 values, basically, RGB. That why you see a black pixel. Otherwise, in the channel, you don't see a black skin as a black pixel. So in the CR channel, what happens like after transforming the color space, that also has some value. So it is more inclined like the same skin pixels will make the clusters of the similar area. So those clusters like data points you have basically, you can say we have a range of 0 to 128, and in 0 to 128, if you make the clusters, you can make how many clusters basically. If we do by 12, we can have like 10 clusters or 12 clusters basically. So everything has a like low range, high range, upper range. So those clusters having the similar tmin and tmax, like skin cluster validity takes place, and you will have those clusters into your account. So those will be having the dark skin pixels into some of the clusters. So that automatically comes into the picture. So that's why we can detect the dark skins also and the light skins. Even we are throwing so much intensity lights because that is carried into the Y dash. So lighting, that's why the color space has been modified into the YCBCR dash. First of all, and then even the YCBCR dash space is also modified. If we see this formula, we have modified the CR dash. So to ensure you will not missing the skin pixels everywhere. Uh, that's the main criteria because skin pixels can variate. That's why the clustering of the algorithm, and this intelligently means we are not giving any data to hard code, because the fuzzy says that it can belongs to the first cluster or second cluster. So if that pixel is belonging to, it has the degree of nature. It will be either belonging to in 12 clusters. It will say I am belonging to third cluster 50% and the fourth cluster 60%. So it's on our part whether we have to choose that pixel into the fourth cluster or then the third. So that way we have a degree of the observation. So this way we making sure that we have the bright skins, we have dark skins, we have lighting variations, we have pose variations. Even the false positive is coming in this. So for that, filtering of intensity done. So higher intensities will be on to the some parts. So that automatically because even the skin color is dark, that intensity values will not be higher at that point. So that this will help further to eliminate the other region. Uh, I hope I am able to answer it. Any other query we can discuss further? So I would like to thank you all for attending this session. And if you have any queries for this session, you can always uh, contact me at my LinkedIn and email. I would be happy to answer you. Uh, I know that my volume was not good due to my headphone or something, a technical problem at my end. But I hope this approach of face detection will help someone, and later on we can discuss any topic around it. So I thank you all. Thanks everyone. Thank you. Bye.